A study is performed to examine the IQ of professional athletes. Of 15 athletes participating in the study, so a sample size of 15, the average IQ is 105. That average came from the sample. It's a sample mean or a sample average of 105. There's a standard deviation of 13. Standard deviation is not preceded by the word population. It is not a population standard deviation. That standard deviation came from the sample of 15. It is a sample standard deviation. We are asked to create a 95% confidence interval, confidence level 0.95, on the population mean IQ, mean being the operative word. As soon as you read that confidence interval bit, recognize that there are three parts. 1, the point estimate, 2, the margin of error, 3, the limits, and then the interpretation. So first, to pick the point estimate. The point estimate is just our best guess for the thing we're trying to estimate, the mean. In this case, that point estimate is x bar, the sample mean. That's our best guess for the population mean. And from the sample, we found a mean of 105. Then the margin of error. This is the most complicated part of the problem. We have to decide on the appropriate formula to use. On the formula sheet that was provided, we notice that we are not in 2 samples. We have information only for 1 sample. Then we decide between mean and proportion. Remember, this question asked for a confidence interval on the mean. So now we're on the top left corner. And now we have to decide between whether or not sigma is known. Sigma is the population standard deviation. The problem did not say population standard deviation. The problem only said standard deviation. So in this case, sigma is unknown. We do not know what the population standard deviation is. That means here we use this formula. Most importantly, this formula used a critical value of t, where the degrees of freedom for that t value are sample size minus 1. So over here, margin of error E, we decided that the margin of error is the critical value of t times the sample standard deviation divided by the square root of the sample size. That's the formula we found from before, from the other page. So confidence level was 0.95. The degrees of freedom were the sample size, 15 minus 1, or 14. We can put this information together to find the critical value of t. This guy's together makes t. But we need the t table. So we have degrees of freedom 14, confidence level 0.95. We'll read the table here. Confidence level 0.95, so that's this column. And our degrees of freedom were 14, that's this row. That means that our critical value of t is 2.145. Now we have all the parts, all the ingredients for this formula for margin of error. So the margin of error is 2.145 times the sample standard deviation S, which is 13, divided by the square root of the sample size, which is 15. So altogether in the formula, in my calculator I got 7.19987. I kept going 60, etc. So that's the margin of error. Now, before we put it into WebWork, round that to 4 decimal places. 1, 2, 3, 4. The 8 looks next door to the 7. The 7 rounds that up. That's 7.1999 to 4 decimal places. To find the lower limit, we simply take the point estimate, 105, and subtract the margin of error. Don't round that margin of error when making the subtraction. And same thing for the upper limit, but remember a plus. Get those upper and lower limits. I got 97.8001 to 4 decimal places, and the upper 112.1999 for the upper limit. So that's the lower limit and the upper to 4 decimal places. And then we make a conclusion. So this part, just like fill in the form, we are 95% confident that the true population mean, this is a form, so that's a pretty generic statement, but we mean the population mean IQ of professional athletes is between this 97.8001 and 112.1999.